Ownership metric number 1. Access friction for job loss benefits. In the last episode, we introduced 6 measurable friction metrics. Now we complete the matrix by examining the final 4, beginning with ownership. The first ownership metric is access friction for job loss benefits. This metric reflects how quickly displaced workers can receive financial support when automation or restructuring eliminates their jobs. It's evaluated as a snapshot and trend hybrid. The current level captures how many administrative steps, approval layers, or waiting periods exist before benefits begin, while the longer-term trend shows whether that process is becoming faster or more restrictive over time. Greater delay and increasing procedural burden correspond to higher ownership friction. This metric matters because hyperefficiency compresses product life cycles and replaces entire categories of work. If a system cannot absorb rapid job displacement and stabilize households during transition, resistance builds and optimization slows, even when the technological gains are real. Ownership metric number 2. Job loss benefit payouts per capita. The second ownership metric is job loss benefit payouts per capita. This metric reflects how much resource reallocation actually occurs when labor demand changes. It's evaluated as a snapshot and trend hybrid. The current level captures how much support is distributed relative to the size of the population, while the longer-term trend shows whether that support is growing or shrinking over time. Lower support levels and declining trends correspond to higher ownership friction. This metric matters because it reveals how tightly a society ties income to employment. If access to basic resources depends almost entirely on holding a job, rapid automation can become socially destabilizing. Systems that allow income to continue during transition can adapt more smoothly as AI and automation reshape large portions of the labor market. Government metric number 1. Protected workforce share. The first government metric is protected workforce share. This metric measures the portion of the labor force whose economic role depends on formal credentials, licensing, statutory authority, or institutional protection, rather than open competition alone. It's evaluated as a snapshot and trend hybrid. The current level captures how large this protected segment is today, while the longer-term trend shows whether that share is expanding or contracting over time. A larger and growing protected workforce corresponds to higher government friction. This metric matters because it reflects the scale of vested interests tied to existing rule structures. When income, authority, and professional identity depend on statutory protection, short-term resistance to change increases even when long-term technological gains may be real. When AI and automation challenge established roles, a larger protected workforce amplifies the political and social cost of rapid adaptation. Government metric number 2. Institutionalized sector share of GDP. The second government metric is institutionalized sector share of GDP. This metric measures how much of a country's economic output depends on statutory allocation, licensing systems, regulated competition, or government-awarded contracts, rather than open market entry alone. It's evaluated as a snapshot and trend hybrid. The current level captures how large this institutionally dependent portion of the economy is today, while the longer-term trend shows whether it is expanding or shrinking over time. A larger and growing institutionalized share corresponds to higher government friction. This metric matters because it reflects how much economic power is tied to rule-defined sectors. When a larger share of GDP is tied to protected groups, disruption affects major revenue streams and organized constituencies. Even a modest increase in that share can create a politically powerful bloc, capable of influencing elections, shaping legislation, and resisting rapid change, when AI begins competing in those sectors. Assigning weights to the friction matrix. With all 10 metrics defined, the next step is assigning weights. These weights determine how strongly each friction factor contributes to the final score. The values shown here are placeholders used to demonstrate the calculation process. They are not derived from historical calibration, and at this stage, there is not enough evidence to justify permanently assigning heavier importance to any single category. As we apply the matrix to multiple countries and observe patterns across cases, a stronger case for calibrated values may emerge. For now, these example weights allow us to show the math clearly while leaving open the broader question of how much influence each factor deserves. Computing the weighted friction score. With the sample weights applied, we now compute the weighted totals. Each metric's average score is multiplied by its assigned weight, and those weighted values are summed across all 10 metrics. We also sum the weights themselves. Because the total weight is not exactly 10, we calculate the average weight by dividing the total weight by the number of metrics. This gives us a normalization factor. We then divide the total weighted score by that factor to remove any distortion introduced by uneven weights. This preserves proportional influence while keeping the overall scale consistent before we compute the final friction value. Returning to the friction equation. Before presenting the final number, we need to reconnect this calculation to the original friction equation introduced earlier in the series. Effective AI productivity was defined as resources plus access plus control multiplied by 1 minus F, the friction scaling factor. That definition requires friction to sit on a 0 to 1 scale. After weighting and summing 10 metrics, the combined value temporarily sits on a 0 to 10 range. That expanded range cannot be plugged directly back into the equation, so we divide by 10 to restore scale compatibility. This converts the total into the average friction score across all metrics. The result is a final normalized friction score of 0.42 for this example. In the next video, we begin applying the friction matrix to real countries.